The first rule is that whenever a ray is drawn parallel to principal axis. So what happens after reflections? In case of a concave mirror, a ray which is drawn parallel to principal axis, as you can see here, if it is drawn parallel to principal axis, it should pass through the focus after reflection. Or in case of a convex mirror, it appears to pass through the principal focus. As you know, the principal focus in case of a convex mirror is behind the mirror, so it cannot penetrate through the mirror. It will appear as if the ray is coming from the principal focus, or you can say it's diverging from the principal focus. Right. So once again, whenever if it is a case of a concave mirror, a ray drawn parallel to the principal axis will pass through the focus, and in case of a convex mirror, it appears to pass. So whenever you make this diagram, make sure you draw the normal. Right. The normal is very important. The normal is here for any concave or a convex mirror. The normal is always the line joining the point of intersection. It's the line joining the point of intersection to that of the center of curvature. This is considered as the normal. Therefore, this will be the angle of incidence and this will be angle of reflection. The same applies for the convex mirror also. It is the line joining the center of curvature to the point of incidence, and this is acting as a normal. And here too also, the angle of incidence will be the incident ray with that of this normal, and angle of reflection will be this. This is the first case, the first rule. The second is, you can say this one. This is just the opposite to what you did. In case if the ray is made to, if a case is when a ray is made to pass through the principal focus, then after reflection it will become parallel. So let's consider the first concave mirror. Here the ray is drawn passing through the principal focus, and after reflection it becomes parallel. And in case of a convex mirror, as it cannot penetrate through the mirror, it lies on the other side. So if a ray is directed towards the principal focus, a ray which is directed towards the principal focus, after reflection it will pass through the parallel to the principal axis. Here too also you have to keep in mind that the normal here is this line joining the center of curvature to the center of curvature to the point of intersection. So this is the second rule. For the third one is the next case, that is the third case. So this says that if a ray is passing through the center of curvature, if a ray is passing through the center of curvature, it is drawn passing through the center of curvature, or maybe directed towards the center of curvature. What do you observe here? That if a ray is directed passing through the center of curvature, after reflection, it will rebound back on the same path, or you can say it will retrace its own path. In case of a concave mirror, in case of a convex mirror, if a ray is directed towards the center of curvature, as you know, it's a center of curvature on the other side. So if it is directed towards the center of curvature, it will rebound back on the same path. Here the normal is the center, this line itself, and that's why we consider here the angle of incidence as well as angle of reflection as 0. So angle of incidence and angle of reflection will be 0 here. Reason being, here the angle formed with the incident ray and the normal is 0, as the incident ray itself is acting as a normal. The last case, when the ray of light is falling obliquely to the pole of the mirror. By obliquely, it means it should not be either parallel or perpendicular, right? Obliquely means with some angle. So when a ray of light is falling obliquely, that means with some angle at the pole of the mirror, the reflected ray also come out with the same angle. So as you can see, this is the angle of incidence. Here, principal axis is acting as a normal line joining the center of curvature to the pole is acting. And so is the case of the convex mirror. You can clearly see in this case that as the angle of incidence decreases, the angle of reflection also decreases. And as we increase the angle of incidence, the angle of reflection also increases. So it says that when a ray is incident obliquely to the principal axis towards the pole of a concave or a convex mirror, in both cases, the incident ray and the reflected ray follow the law of reflection, and at the point of incidence, they make equal angle. This is true in case of a convex mirror. So these are the 4 rules that you have to keep in mind while making a ray diagram. And as I said, for obtaining the image, any of these, out of these 4, any 2 is needed. So according to the convenience of drawing, you can use any of these 2 to make the ray diagram.